Hi everyone, today we'll be looking at the October 2020 Pure Mathematics 1 paper. You can see that the labeling is May 2020. These are the exams that got cancelled because of the COVID-19 pandemic. In question 1, given that 3pq squared all to the power of 4 times 2p times the root of q to the 8 is equivalent to ap to the b, q to the c, we need to find the values of a, b, and c. So this is really an indices questions. We need to make sure that we apply the rule of indices carefully here. So the first thing we need to do is look at 3pq squared all to the power of 4, which is 3 to the power of 4, p to the power of 4, q to the power of 8, because when we raise a power to a power, we multiply the indices together, times 2p, and the root of q to the 8 is obviously q to the 4. Now 3 to the power of 4 is 81. P to the power of 4 times p is p to the power of 5. Q to the power of 8 times q to the power of 4 is q to the power of 12. And I also have the 2 there. So all of this is 162. P to the power of 5, q to the power of 12, which means that A is 162, B is 5, and C is 12. In question 2, we're given f of x here a quadratic expression and we need to put it in the form. So we need to complete the square. Actually, there are two approaches we could follow here. The first one is start by writing f of x as 3 plus 12x minus 2x squared. I actually prefer to have the x squared term first, then the x term, and then the constant. And then I will force a factor of -2. So it's going to be -2x squared minus 6x, and the plus 3 stands outside the bracket. I will complete the square here. It's -2 bracket x minus 3 all squared minus 3 squared plus 3, which is -2 x minus 3 squared minus 9 in brackets plus 3, which is -2 brackets x minus 3 squared plus 18 plus 3, which leads to 21 minus 2 brackets x minus 3 squared. So this means that A is 21, B is 2, and C is -3. Now, an alternative approach would be to actually use the form of the answer given. So we could say that 3 plus 12x minus 2x squared is equal to A minus B brackets x plus C squared. I will expand the right hand side, so it's going to be A minus B brackets x squared plus 2cx plus c squared. And upon a further expansion, I get A minus bx squared minus 2bcx minus bc squared. And all I need to do here is compare coefficients. So if we look at the coefficient of x squared, it's -2 here, and here it's -b. So -2 is equal to -b, which means that 2 is equal to b. I will now look at the coefficient of x. It's 12 on the left hand side, and it's -2bc on the right hand side. So 12 is equal to -2bc, but we know that b is 2, so we get that 12 is -4c, so -3 is equal to c. And finally, for the coefficient, the constant, the 3 here, it's a minus bc squared. So 3 is equal to a minus bc squared. We know that b is 2 and c is -3. So 3 is a minus 18. So a is 21. So that would be an alternative way of finding a, b, and c. Now the curve with equation y is f of x minus 7 crosses the x-axis at the points P and Q and crosses the y-axis at the point R. Find the area of triangle PQR, giving your answer in the form m root n, where m and n are integers to be found. So I will start by saying that I'm dealing with y is f of x minus 7, which according to the work done in part A is simply 21 minus 2 brackets x minus 3 squared minus 7, so it's 14 minus 2 brackets x minus 3 squared. Now at P and Q, the cuts on the x-axis, y is 0, which means that 14 minus 2 brackets x minus 3 squared is 0. So it's actually useful that we have put f of x in this particular form. So 14 is equal to 2 brackets x minus 3 squared. 7 is x minus 3 squared. So plus minus root 7 is x minus 3, which means that 3 plus minus root 7 is x. So these are the x coordinates of P and Q, and therefore the 2 points will be 3 plus root 7, comma 0, and 3 minus root 7, comma 0. Now we also have the cut on the y-axis, that's point R. So at R, x is 0, which means that y is 14 minus 2 times 0 minus 3 squared, which is 14 minus 18, which is negative 4, and therefore the point here is 0 minus 4. Now I'm being asked to find the area of triangle PQR, so it makes sense to draw a quick sketch to see exactly where the vertices of this triangle lie. We have drawn the triangle. This is P, this is Q, this is R. We're trying to find the area shaded here in red. It's obvious that the distance here is simply 2 root 7, and the height here is 4, and therefore the area of the triangle will simply be base times height over 2, which is 2 root 7 times 4 over 2, which is 4 root 7 square units. Question 3, we've got the design for a batch. We have two congruent triangles, two identical triangles, AOC and BOC, and it's a sector AOB with an angle of alpha at the center, and we're being given the dimensions here. The radius is 3, the distance OC is 5. We need to show that alpha is 1.6 radians, given that the area of the sector is 7.2 square centimeters. We know that the formula for the area of a sector is a half r squared theta, provided theta is in radians. So 7.2 is a half times 3 squared times alpha. So 7.2 is 4.5 alpha. I divide by 4.5 and we recover that alpha is 1.6 as required. Hence, it says in part B, find the area of the batch and the perimeter of the batch. Now, to find the area and the perimeter, I need to consider the angle here. We know that this is 360 degrees or 2 pi radians, and because the two triangles are congruent, it means that these two angles are the same. Therefore, this is 2 pi minus alpha over 2. And this is also 2 pi minus alpha over 2. So, to find the area, I know the area of the sector here, so I will simply be adding twice the area of this triangle, and I'll be using a half AB sine C to do that. So, the total area for part B, the area will be 2 times a half AB sine C. So the angle in between, 2 pi minus alpha over 2, plus the area of the sector, which was given to be 7.2. Now we have found that the value for alpha, it's given actually to be 1.6. So I will simply substitute alpha with 1.6. And this allows me to plug everything on the calculator. I get 17.96 squared centimeters, which to 2SF is simply 18 square centimeters. Now for the perimeter, I need to find the length of the arc, and then AC, which I will double because CB is also the same length. I will be using the formula for the length of an arc, r theta, to find AB, and I'll be using the cosine rule to find AC. So let's start with the arc AB, which is simply r theta. So it's 3 times 1.6, so 4.8 centimeters there. And then cosine rule, AC squared is 3 squared plus 5 squared minus 2 times 3 times 5 cos of the angle, which is 2 pi minus 1.6 over 2. Plugging this on the calculator gives me 54.9012, and therefore if I take the square root of this, it's going to be 7.4095 centimeters. Notice that I'm maintaining intermediate answers to a greater degree of accuracy than the final answer. The perimeter will simply be 2 times AC plus the length of the arc, which is 19.6 centimeters to 3 significant figures. In question 4, we need to use algebra to solve these simultaneous equations. We can see that the first one is a linear one and the second one is a quadratic one. So I will be using substitution to go from the linear into the quadratic. It makes sense to make y the subject, so y is 3x plus 4, and substitute this into the second equation. So x squared plus 3x plus 4 all squared plus 6x minus 4 times 3x plus 4 is equal to 4. I will now expand x squared plus 9x squared plus 24x plus 16 plus 6x minus 12x minus 16 is equal to 4. And it's now a matter of collecting like terms together. We've got a total of 10x squared. I've got 24x plus 6x is 30x minus 12x is 18x. And then looking at the constants, 16 minus 16 is 0, and the 4 moving on to the left hand side will be minus 4. It makes sense to divide everything by 2, so 5x squared plus 9x minus 2 is 0. And then this factorizes into 5x minus 1, x plus 2 is 0, which means that either 5x minus 1 is 0 or x plus 2 is 0. So 5x is 1, x is 1 over 5, or x is negative 2. We haven't finished. We need to go a step further and find the corresponding values for y. I will be substituting into y is 3x plus 4 to find the values for y. So when x is 1 over 5, y is 3 times 1 over 5 plus 4, which turns out to be 23 over 5. And when x is negative 2, y is 3 times negative 2 plus 4, which is negative 2. In question 5, we are being given a sketch of f of x. We clearly see cuts on the x-axis at minus 5 and 2, and a cut on the y-axis at negative 3. And on separate diagrams, we need to sketch the curve with the equation y is f of x plus 2 and y is f of minus x. So first of all, let's consider what kind of transformations we are looking at. F of x plus 2 is a translation 2 units to the left. So it is clear that the cut on the x-axis at 2 will come and sit exactly on the origin. The -5 will go to -7, and that's going to be the graph of f of x plus 2. The graph of f of minus x, well, I'm multiplying all the x's by -1. So essentially, I'm doing a reflection along the y-axis because the positive x's become negative x's and vice versa. So we've got this interchange along the horizontal. So it's a reflection along the y-axis. Now, in such questions, we need to be careful on what exactly we should be including on our sketch, and it is clearly stated here that we need to show the cuts on the coordinate axis. So, for f of x plus 2, I will start by drawing the original graph just to see exactly the transformation. So this is the graph of f of x, the original graph, and we can see that we are moving 2 units to the left. So it should look something like this. So it's coming over here exactly. We've got the cut on the x-axis at -7, and then we've got the touching point here on at the origin. So this is the graph of f of x plus 2. For part B, we said that the transformation y is f of minus x corresponds to a reflection along the y-axis. It's obvious that the cut at -5 will now come at 5. The cut at 2 will go to -2, and the cut on the y-axis will remain there. It's invariant, this particular point, and therefore we expect the graph to look something like this. So this is the 5, this is the -2, this is the -3, so this is y is f of minus x. In II, we've been provided with a sketch of the curve with equation y is k cos of x plus pi over 6. We are told that the curve meets the y-axis at 0√3 and cuts the x-axis at p0 and q0, and we're being asked to find the value of k and the values of p and q. Now, the k outside is a stretch along the vertical, and the x plus pi over 6 is a translation along the horizontal, pi over 6 to the left. I will start by finding the value of k, and I will be using the fact that we pass through the point 0√3, which means that when x is 0, y is √3. So I will substitute into the equation y is k cos of x plus pi over 6. I will substitute y with √3 and x with 0. So it's cos of pi over 6. Now cos of pi over 6 is √3/2. The √3 cancels out on either side, and I cross multiply to get that 2 is equal to k. Now, for p and q, the cuts on the x-axis, I will start by considering the graph of cos without any transformations. So we know that it goes like this, and we've got cuts at pi over 2 and 3 pi over 2. So this is the graph of cos of x. Now, looking at the graph we've been provided with, the x plus pi over 6 means that we are looking at the translation by pi over 6 to the left, which means that we deduct pi over 6 from all x values. So the value of p is simply pi over 2 minus pi over 6, which turns out to be pi over 3. And the value of q is 3 pi over 2 minus pi over 6, which is 4 pi over 3. Essentially, everything has been shifted by pi over 6 to the left, and so did the two cuts on the x-axis. In question 6, we start off with being given 2 points, A and B, and we need to find the gradient of AB. I will be using the fact that the gradient is y2 minus y1 over x2 minus x1, which means that I will substitute 2 minus 11 over 8 minus 4, which is minus 3 over 4. Now, the point M is the midpoint of AB, and the line L passes through M and is perpendicular to AB. So let's start with the fact that it's perpendicular. It means that the gradient of L is 4 over 3. I'm using the fact that if two lines are perpendicular, then the product of their gradient is -1, and it's really handy to just flip and change the sign to get the gradient of the perpendicular. Now for the midpoint of AB, I'm doing the midpoint of the x's and then the midpoint of the y's. So it's going to be minus 4 plus 8 over 2, comma 11 plus 2 over 2. So the coordinates of M are 2, comma 13 over 2. And now I have the gradient and the point through which I pass. So I'll be using y minus y1 is mx minus x1, which means that y minus 13 over 2 is 4 over 3 x minus 2. It makes sense to start off by expanding. I need to give my answer in a particular form. So y minus 13 over 2 is 4x over 3 minus 8 over 3. We can see that the LCM here is 6. So 6y minus 39 is 8x minus 16. I will collect everything on one side. 6y minus 8x minus 23 is 0. And this is really giving the equation of the line in the form required in the question. Now, we've got a point C lying on L such that the area of triangle ABC is 37.5 square units, and we need to find the two possible pairs of coordinates of point C. Now I see that this particular part is 5 marks, which means there is quite an extensive bit of work involved here. So it makes sense to invest a couple of minutes drawing a nice sketch to get a visual understanding of what's happening. I know I've got two straight lines, they are perpendicular, they meet at M. So I'll try and draw a sketch to see exactly what's happening here. So this is my sketch. I've got the straight line L having a gradient of 4 over 3, so it's going uphill. We've got the line AB perpendicular, so the angle here is 90 degrees. The midpoint is 13 over 2, sorry. And then somewhere along the line L, we've got a point C, such that the area of the triangle ABC is 37.5 units. And there are actually two possible positions because it could be either on the right hand side or on the left hand side. That's an alternative for C. And we need to find the position, the coordinates of C. I will start by finding the distance AB because obviously this is the base of the triangle. So the distance formula says that it's y2 minus y1 squared plus x2 minus x1 squared square root. It's Pythagoras theorem here. So this will be 8 minus 4 all squared plus 2 minus 11 squared square root, which means that this turns out to be 15. The area of the triangle is 37.5, which is a base of 5 times the height over 2. I will cross multiply to get 75 is 5 times the height, and therefore 15 here, so this is 15. So the height is 5. Now the height is simply the distance here. And I just need to focus for a moment on the fact that the gradient here is 4/3, which means that the rise over run is 4/3. So if I was to draw a triangle here, a right angle triangle here, this is the rise and this is the run. And it's a 3, 4, 5 triangle, which is really helpful in the sense that I wanted all of these to be 5. So it means that I could actually update this here and say that this is 3, this is 4, and this is 5. Which simply means that to find the coordinates of C here, I will go 3 to the right and then 4 up. So from 2 I will add 3, from 13/2 I will add 4, and therefore one possible coordinate for C will be 5,21/2. That will be the case of being on the right hand side. Or it could be this way, which means I go 3 to the left and then 4 down. So I deduct 3, I go to -1, and I deduct 4 and I go down to 5/2. There were other ways you could actually approach this, but I think this is the most efficient way. It avoids unnecessary algebraic work. You just look at the gradient. We just happen to be lucky enough that it's a 3, 4, 5 triangle, and the 5 is exactly what we were looking for in order to have the appropriate height that will give the necessary area of 37.5. In question 7, the curve C has equation y is 1/2 minus x, and we need to sketch the graph of C. Well, we know that this is a reciprocal graph, so it has asymptotes. We actually have been asked to state the coordinates of any points of intersection and the equations of any asymptotes. So the first thing we notice is that when 2 minus x is 0, we've got division by 0, which means that we've got an asymptote. So we've got an asymptote at x is 2. We also have an asymptote at y is 0. The x-axis is an asymptote as well. In order to see this, we can see that as x grows to infinity, 1/2 minus x tends to 0, because we've got 1 over something very big. So it tends to 0, and therefore y equals to 0 is an asymptote. I can also say that when x is 0, y is a half. So that's the cut on the y-axis. So we can now sketch this. So we draw a pair of axes, x and y, and we will be adding first of all the asymptote at x is 2. It's a vertical asymptote. Remember, we need to provide the equation, so x is 2 and y is 0, and then it's like this with a cut at a half. That was part A for 3 marks. Now part B, the line L with equation y is 4x plus k, k is a constant, meets C at 2 distinct points, and we need to show that k squared plus 16k plus 48 is greater than 0. So essentially we're looking at the points of intersection of y is 1/2 minus x and y is 4x plus k. If I equate the two, I get 1/2 minus x is 4x plus k, and therefore I can cross multiply into 1 equals 4x plus k brackets 2 minus x. I will expand this, it's 8x minus 4x squared plus 2k minus kx, and I will collect everything on the left hand side, so 4x squared minus 8x plus kx plus 1 minus 2k is 0. I will put it in the standard form of a quadratic expression, so 4x squared plus k minus 8x plus 1 minus 2k is 0. Now, for two distinct cuts, it means that the discriminant is greater than 0. So that we have two distinct solutions. And the discriminant is b squared minus 4ac. These are the coefficients here, the a, the b, the c. So the discriminant is b squared minus 4ac, which has to be greater than 0 for two distinct cuts. I will now expand. I get k squared minus 16k plus 64 minus 16 plus 32k is greater than 0. So k squared plus 16k plus 48 is greater than 0 as required. And then in part C, hence find the range of possible values for k. We're obviously looking at a quadratic inequality. I will start by factorizing into k plus 4, k plus 12. We see that the critical values are negative 4 and negative 12. So if I was to sketch this, it's a smiley parabola. And we've got the cuts at negative 12 and negative 4. It goes plus, minus, plus, and we want to be positive. So the solutions are on the tails. So it's all k such that k is less than negative 12, or all k such that k is greater than negative 4. So these are the solutions we get here. Question 8. We are being given this cubic, y is x minus 2, x minus 4 squared, and we need to show that the y dx is 3x squared minus 20x plus 32. And I can only start by expanding the expression for y. So we have x minus 2x minus 4 squared. I will expand the square to get x minus 2, x squared minus 8x plus 16, which is x cubed minus 8x squared plus 16x minus 2x squared plus 16x minus 32, which is x cubed minus 10x squared plus 32x minus 32. Now let's differentiate dy dx. Well, I get the power down, deduct 1 from the power, minus 20x plus 32 as required. That was 4 marks. So we expand and we differentiate. Now the line L1 is a tangent to C at the point where x is 6, and we need to find the equation of L1 giving our answer in the form y equals mx plus c. So the first thing we can do is actually evaluate dy dx at x is 6. So we substitute x with 6 in the expression for dy dx. This is giving an answer of 20. That's the gradient of L1. We also need the value of y, so when x is 6, y is 6 minus 2 brackets 6 minus 4 squared, which is 16. So I'll be using y minus y1 is mx minus x1 to get y minus 16 is 20x minus 6. I haven't finished. I need to put in the form y equals mx plus c. So y minus 16 is 20x minus 120, which means that y is 20x minus 104. That's the final answer for part B. And then part C, we've got the second line L2, which is also a tangent to C at the point where x is a. Given that the two lines are parallel and distinct, find the value of alpha. Now, the fact that the two lines are parallel, it means that they have the same gradient. So if I go back to the expression for dy dx and I substitute x with alpha, I'm expecting to get the same answer of 20, the same gradient. So substituting alpha, it's 3 alpha squared minus 20 alpha plus 32. Collect everything on one side, it's 3 alpha squared minus 20 alpha plus 12. I will factorize this into 3 alpha minus 2, alpha minus 6. I get two solutions. Either 3 alpha minus 2 is 0 or alpha minus 6 is 0. So this means that 3 alpha is 2, so alpha is 2 over 3, and alpha is 6. Well, alpha is 6 corresponds to line L1 because we knew that x is 6 there. So I have to reject this. I need to show explicitly the rejection, and I'm left with alpha being 2 over 3. 9, we start off with f of x. We know that it passes through the point 9, 10, and we are being given an expression for f dash of x, the derivative of f of x, and we have to find f of x, fully simplifying each term. So I will start by writing f dash of x in a form that allows integration to happen, because I need to integrate to go back to f of x. So f dash of x is 27x squared minus 21x cubed over 2x to the half plus 5x over 2x to the half. Be careful with the plus here because of the double negative. So minus minus gives me a plus. So this is 27x squared minus 21x to the 5 over 2 over 2 plus 5x to the half over 2. This is f dash of x. Now to find f of x, I will integrate 27x squared minus 21 over 2 x to the 5 over 2 plus 5 over 2 x to the half dx. So we increase the power by 1, dividing by the new power, 27x cubed over 3 minus 21 over 2 x to the 7 over 2 over 7 over 2 plus 5 over 2 x to the 3 over 2 over 3 over 2 plus c. We do have some simplifications. The 27 with the 3 leaves me a 9. The 21 with the 7 leaves me a 3, and the 2 with the 2 go away, and the 2 with these 2 go away. So I end up with this being 9x cubed minus 3x to the 7 over 2 plus 5 over 3x to the 3 over 2 plus c. The plus c is the constant of integration, and I'm actually going to be using the fact that f of 9 is 10 to find c and complete the answer. So f of 9 is 10, which means that 10 is 9 times 9 cubed minus 3 times 9 to the 7 over 2 plus 5 over 3, 9 to the 3 over 2 plus c. So I will plug all of these onto the calculator. It gives me an answer of 45. So 10 is 45 plus c, which means that c is minus 35. And the only thing left to do is write f of x explicitly. It's 9x cubed minus 3x to the 7 over 2 plus 5 over 3x to the 3 over 2 minus 35.